is just this, pay attention in this tutorial क्योंकि थोड़ा सा important है, ठीक है? And if you have doubts, you can unmute and speak. So because I'll be on the other screen, so I'll keep looking at the chat, but you can unmute and ask your doubts. Okay, so let's start with RLC circuits. Start with question number 5. So we have a series RLC circuit, and I'll start from scratch. We'll write the KVL, we'll form a second order differential equation, and I'll tell you all the three cases. So first of all, we have a voltage source, we have a resistor, we have an inductor, and we have a capacitor. Okay, so let's just call this RLC, and this is V. Okay, so this is, right now we are in DC only, so this is a DC source, and we'll say that some I current is flowing, and this I current would be changing with time because we have energy saving components L and C. So if I start to write the KVL, my KVL would begin as V minus IR minus L di by dt minus Vc is equal to 0. Is this much fine? So now what we have to do is we need to convert this Vc component into a function of current. So if my R, L and C are all in series, this means that the same I current is flowing through all of them. And we know that the current across a capacitor can be given by C dVc by dt. Right, this is the equation for current across a capacitor. So from here, we can actually solve for Vc, as Vc will equal to 1 over C integral I dt. Right? Is this fine? Is there any doubt here? Okay. So after we found the expression for Vt in terms of I, we are just going to put this expression into this equation. So we will get V minus IR minus L di by dt minus 1 over C integral I dt is equal to 0. Okay. So also the limits of this integral are from 0 to t, but it doesn't matter because we're going to get rid of that integral anyways. So now to form a differential equation, we will divide this entire equation with respect, sorry, we'll differentiate this entire expression with respect to dt once again. So if I do that, this V is just a constant, right? This is the source voltage. This is a constant. So if I differentiate it with respect to dt, this will just go to 0. So we will have something like 0 is equal to, I'm taking all of these components to the right side of this equal to sign, so they'll all get plus now. So 0 is equal to R di by dt minus L d2I by dt square minus 1 by ci. Sorry, plus. Okay, all these three things become plus. So now we have a second order differential equation, and we'll divide all of this equation by L so that we don't have any coefficient for the second order part of the differential equation. So if I divide the entire equation by L, I get d2I by dt square plus R by L di by dt plus 1 over LC times I is equal to 0. So this is your general differential equation in case of a series RLC circuit, right? Is there any?
हाँ, इसमें डाउट है, हमेशा प्लस ही आएंगे, मतलब इनके बीच में कभी माइनस नहीं आ सकता?
अगर कोई प्री चार्ज कंडीशन वगैरह कुछ नहीं है तो फिलहाल तो प्लस, हमने तो नॉर्मल केवीएल से डिराइव किया ना, प्लस क्यों आएगा? या तो तीनों नेगेटिव हो जाएंगे या तीनों पॉजिटिव हो जाएंगे, कोई इनिशियल कंडीशन चेंज वो देखना पड़ेगा यार। अभी पहले ये कर लेते हैं, वो बाद में पूछ लेना, ठीक है? Okay, so now see, there is a little bit of math. So in differential equations, what you have is, if you have a second order differential equation, let's say like this, y dash plus ay dash plus by is equal to 0, right? So what we do is we assume that our solution is of the form y is equal to e to the power mx or rx, anything, doesn't matter, m is just a constant here. So we would assume that our solution is of this form. So if I find I y dash, I'm going to get m e to the power mx, and y double dash would be m square e to the power mx. Is there any problem in this? No. Okay. So what we do is you just put these terms back into this equation, right? So what is eventually going to happen is this e to the power mx would just come out to be a common term, m square plus am plus b into e to the power mx is equal to 0. This would just come out to be outside the, I mean, a common term, e to the power mx, and this can just get cancelled because we can shift it over there, and what you left will be this. So this is the characteristic equation which we normally get while we are solving the differential equations for second order. So is this fine? Where does this characteristic equation comes from basically? So this is the way that it comes from. Okay. So what we have is we have this uh, yeah, we have this differential equation, and we've seen that the characteristic equation which comes is will be of the form this. Right. So now what we are supposed to do is we are supposed to solve for m1 and m2. So there are three cases which are possible. Case 1 is that m1 and m2 are both real and unequal. Okay. So if this is the case, can someone tell what will it means in terms of R by L and 1 over LC if they're both real and unequal?
R by L square minus 4 by LC greater than 0.
Right. So if I write the solution of this equation, it would basically be minus R by L plus minus under root R by L whole square minus 4 by LC over 2. So this will be in general m1 and m2, right, for this equation. So if m1 and m2 are real and unequal, this means that the discriminant, or this means that this discriminant is greater than 0. So for it to be greater than 0, it means that my R by L whole square has to be greater than 4 by LC. And if this is the case, then this is what you call as your overdamped condition. And now the thing that you have to remember is that in case you have an overdamped condition, in case your m1 and m2 both come out to be real and unequal, then the solution of your differential equation will be of the form this. This you have to remember. a1 e to the power m1t plus a2 e to the power m2t. So this will be the solution of your differential equation in this case. Okay. So then you have your second case. In case 2, m1 and m2 are real and equal. So now can someone tell what will this mean? Actually, I'll just do it quickly. So if they are real and say whoever was just unmuted.
ये R by L का whole square equals to 4 by LC हो जाएगा.
Right. So if they are real and equal, this means that this discriminant part has to go to 0. Right. So this means that R by L whole square equals 4 by LC. So R by L whole square is equal to 4 over LC. And this is your critically damped case. Right. And again, the only thing that you need to remember is what sort of a solution you have in case of a critically damped case. The solution will take the form a1 e to the power m1t plus a2t e to the power m2t. These a1 and a2 are, by the way, some constants which you have to figure out using initial conditions, which I'll show you how they are done. And case 3 is if m1 and m2 are complex. So if these expressions are complex, that this means that they will occur as conjugate pairs. So complex solutions occur as conjugate pairs. So if m1 and m2 are complex, then it will mean that r by l whole square is less than 4 by lc, and this is your underdamped case, right? And if you have this case, then your solution will take this form. Wait, let me think. It is e to the power lambda t uh, a1 cos mu t plus a2 sine mu t. Okay, and this lambda and mu is nothing but your m1 say equals lambda plus mu, and m2 sorry mu j, and this equals lambda minus mu j. So this is the solution that you'll get in case of an underdamped system. Okay, are all the three cases clear? Okay, so now let's go to our question and see. I'm running these three cases. Okay, so in the question, what are the values of R, L, and C given to us? I think R is, someone tell me, 20 ohms.
L is 0.01,
0.01, and C
100 microfarad.
100 microfarad. Okay, so we can put these three values in the, actually we don't have to even do that. So what did we see? We saw that if we need to compare basically r by l whole square with 4 by lc. We need to compare this r by l whole square with 4 by lc. So you can put the values and check. So we will get equal here. Both of them are equal. So if we compute r by l whole square, it would be same as 4 over lc. So we will have a critically damped case. Right. So if we have a critically damped case, first of all, we need to find that real unequal root. So our roots will be real unequal. So let's start by finding the root. Okay. So our differential equation is double dash plus 20 over 0.01 I dash plus 1 over 10 to the power minus 6 I is equal to 0. Is this fine how I wrote this? Okay. So this will be I double dash plus 2000 I dash plus 10 to the power 6 I is equal to 0. So just the same way we will find the characteristic equation. The characteristic equation will be m square plus 2000 m plus 10 to the power 6 is equal to 0. This will be our characteristic equation. And we need to solve this quadratic equation. Solving it, we would get m1 is equal to m2 is equal to negative 1000. So this will be a root of the quadratic equation, which is negative, and both are equal. So in case I told you when the roots are equal, so what is the form of your solution? If anyone remembers.
A1 e raised to power m1t plus A2t e raised to power m2t.
Right. So in general, this becomes a1 e to the power minus 1000 t plus a2 t e to the power minus 1000 t. Okay, now is basically the part where you have to think that how will you figure out these a1 and a2. So does someone have any suggestion of how to find a1 and a2?
We have to use initial condition for
Yes.
IT and I dash t.
How will you use it for I dash t?
uh, using the voltage across the inductor.
Right. So okay, so we will start by the first initial condition. So at t equals to 0, I equals 0. So because we only, this is obvious, right? At t is equal to 0, I equals 0. Because the circuit switch has been closed at t equals to 0. So at this moment, our inductor is an open circuit, and so just before the switch has been closed. So at t is equal to 0, I equals 0. So if we put this initial condition into our expression, we will get that a1 e to the power minus 1000 t is equal to 0. The other part will just go to 0 because it already includes a t term here. Right, so we will get this. So this will imply that a1 is 0. So right now we have found that a1 is 0. So our current takes the form this. Now how do we find this a2 term? Okay, so I'll go to the figure once. Now see. Okay, so in this figure, see, just after the switch has been closed, what will be the current in the circuit? Just after the switch has been closed,
0.
right? The current will be 0 because current across the inductor does not change instantaneously. So it will just be 0. So this means that I of 0 plus is also 0. Now what will be VL of 0 plus?
100 volts.
Right. This will be 100 volts because at 0 plus or just the instant when the switch is closed, the inductor behaves as an open circuit. So if it is an open circuit, this means that all this V volt would drop across this inductor only. So here we can see an example where the current is not changing instantaneously. For example, at 0 minus it was 0 only because the switch was open, but VL was also 0. But at 0 plus, VL has become 100 volts even though current is the same. So current across an inductor will not change instantaneously, but the voltage can change instantaneously. So when we write this L di by dt, this di by dt is in general the rate of change of current, not for this instance. So what we can do is we can use this second condition in which we have found that VL of 0 plus is 100 volts. So if I different, so basically L di by dt is 100 volts. So you can differentiate IT. So upon differentiating, we will get something like, so e to the power minus 1000 t. If I use the product rule, so first I keep this outside, I differentiate t, then I keep t inside and I differentiate the other part. Is this fine? Now this is VL of t. So now we need to evaluate this also at 0 plus, which is just basically 0 only. So if we put in 0, we will get A2 over 100 into 1. Yeah, that is it. So VL of 0, we found that this was 100. So into 100 is equal to A2. So your A2 becomes 10 to the power 4. So in general, the expression of current becomes 10 to the power 4 t e to the power minus 1000 t.
Can you just go through it again? How you found out A2?
Yeah, sure. Okay, so uh, at t equals to 0 plus, right after the instance when the switch was closed, what will be the current in the circuit? Can you tell? What will be the current in the circuit just after the switch has been closed?
0.
Right. It will just be 0 because uh, this is a DC source right now. So at the instance when the switch is just closed, inductor behaves as an open circuit. So if the circuit is open, you don't have any current in the circuit. So at 0 plus also, the current remains 0. But since the inductor is an open circuit, this means that all of this V voltage, like whatever the value of the source is, all of this would be shown across this inductor only. So this means that VL of 0 plus would be 100, but the current will be 0. So what I did was I found the expression for VL, which is nothing but I di by dt. And you have already found the expression for I. So I just differentiated it with respect to dt multiplied by L. So you get VL is equal to L di by dt over here. And then I just put in the value of 100 in here to solve for A2. Is that fine, whoever was asking the doubt?
Yeah, okay, got it. Thank you.
Okay. So is there any other doubt in RLC system? Okay. So I'll move on to the transient part then. Okay. So I think I'm not sure if I'll be able to cover all the questions. I'll try to, but I'll give you a general idea, and the same is to be applied in every question basically. So let's consider two scenarios for an LR circuit. So, okay, now consider these two cases. I mean, this is not something like that. This is a representation of this after t is equal to 0. No, these are two different cases. Okay, right now. Can anyone tell me any difference between these two cases? I mean, what is the difference between these two cases? If I ask you to find the expression of current, find I of t for t greater than equal to 0. Okay, I want you to do this in both the questions. So, will there be any difference in the answer, or will the answer of both these questions be the same?
ये दूसरे वाले केस में रेफरेंस मतलब है क्या, पहले वाले में तो पता लग रहा है.
दूसरे वाले में वही कोई रेफरेंस नहीं है ना, सो कभी भी पास्ट में बंद हो सकता है स्विच. So basically what we assume is कि infinite time पहले switch was closed. So we are reviewing the circuit for r t is equal to 0, but the switch has been closed for infinite time. So will there be any difference in both of these questions, or will the answer be same?
Initial conditions will be different, so the value of constants will get different.
This is a AC circuit right now. We will not be forming that second order differential equation which we did in a DC case.
So,
Okay. So there is a little bit difference between these two cases. So you can assume that this question is basically a subset of the previous question. So whenever we close the switch, or whenever you have something like suddenly a voltage was applied or suddenly the switch was closed at t is equal to 0, this means that there will be some transients in the circuit. So basically, hopefully you'll do this in your theory class also. So basically in case of AC circuit, so let's say an ACLR circuit, the general form of current is basically I transient plus I steady state. And here steady state does not means that inductor will get shorted at t is equal to infinity because you have an AC source. Here steady state just means the time when the transients have died down. I'll show you why we need this transient part. So right now I don't think we have any question which includes this. We have the questions which include this. So in this question, so which we will be doing at t is equal to 0, the switch has been closed, we will find the steady state current, which we need to do in this case. But we will also be finding the transient current, which we do not have to do in this case, because here we assume that the transients have died down. because the circuit was long for infinite amount of time before. And one more thing which you need to know, that transient current will take this form, a e to the power minus t by tau. So now you can see if t goes to infinity, all of this term goes to 0. So that's why transients die down in the second case, because the switch has been closed for infinite time. So this would probably be covered in your theory class also, and hopefully it will be more clear then. So right now I'll just move to question, and you can remember that this will be the form of your transient part. And just remember that there is a difference between those two cases. If the switch has been closed at t is equal to 0, the switch was long closed. Okay, so let's go to the second question. So what we have is AC source, resistor, and an inductor. So this is 200 sine 314t. This is 10 ohms, and this is 0.1 Henry. Okay, now it has been given that the voltage has been suddenly applied at t is equal to 0. This means that the switch is closed at t is equal to 0. So if the switch has suddenly been applied, I mean, if the voltage has suddenly been applied or the switch has just been closed at t is equal to 0, this means that we need to account for the transient part as well. So, one second. Yeah. So in general, our I of t would be transient part plus the steady state part. So first we'll start by finding the steady state part only, right? First we'll just ignore this and only find the steady state part. I mean, not ignore this in general, but just to find steady state part. Okay, so to find steady state part, you need to do three things. So first of all, we'll convert this from time domain into our phasor part. So does anyone know what will the phasor notation for this be? How will we write in terms of phasor?
We have 200 by root 2 or e raised to power, I guess, minus 5.
Okay, so you can do all that, but see, basically our main aim is to convert this into some form of this thing. So this 200 is just the amplitude, and this 0 is the phase. Here you have no phase, here your angle is 0, so you will just write 0 over here. So this is also a notation in which you can write the value, or the basically the modulo and the angle, the phase which it incorporates. So we will be dealing with situations like these, and you can use calculators, you can use Python to solve what different angles will do. So basically, it's here we just have a 0 degree angle, but we can have something else as well. So if we have, let's say, 200 angle, 60 degrees, etc. So there are things that can convert this into x plus jy form. So if you're more comfortable with complex numbers, you can solve it like that also, or
भैया
you can directly do calculations over these using calculators.
ये तो 200 साइन 314 टी है, इसका फेजर ये है 200 एंगल 0.
हाँ, पर अगर हम इसको कॉस में कन्वर्ट करेंगे तो एंगल
हाँ,
चेंज हो जाएगा.
मैं वही पूछ रहा था कि कॉस में जब होता है तब लिखता है, फिर कैसे भी लिख सकते हैं, मतलब
दोनों में लिख सकते हैं, बट इफ यू आर राइटिंग इन साइन देन ऑल योर आंसर्स विल बी फाइनली इन साइन. उनको कॉस में मत चेंज कर देना. इफ यू आर राइटिंग इन कॉस देन ऑल योर आंसर्स विल बी इन कॉस. इट डजंट मैटर तुम स्टार्ट साइन से करो या कॉस से करो.
बुक में लिखा हुआ था ना कि जब कॉस में हो तब करो, तो बुक में लिखा हुआ था
साइन में करने से मना किया.
कॉस वाला लिखा हुआ था उसमें कि जब कॉस में होता है तब कन्वर्ट करते हैं, मतलब वो सबको पहले कॉस में कन्वर्ट कर रहे थे साइन के फंक्शन को भी.
हाँ, वो कर सकते हो, उसमें कोई प्रॉब्लम नहीं है, बट अगर साइन में है तो भी आई डोंट थिंक कोई प्रॉब्लम होती है. यू कैन
और
सॉल्व.
एक चीज और भी कर रहे थे, वो रूट 2 से डिवाइड भी कर रहे थे, मतलब इफेक्टिव वैल्यू ले रहे थे.
वो आरएमएस के लिए होगा ना.
हाँ, तो वो
But-
एम्पलीट्यूड नहीं ले रहे थे, वो जैसे 200 है 200 बाय रूट 2 कर रहे थे.
हाँ, वो आरएमएस होगा, बट इस केस में वी आर अज्यूमिंग कि हमें आरएमएस ही दिया है, सो इट्स ओके. आई मीन दैट इज फाइन, वैल्यूज कैन वो कोई बात नहीं है, वो आरएमएस और उसके लिए.
आंसर चेंज होगा ना पर उससे, तो फिर
सिर्फ मॉड्यूलो पार्ट चेंज होगा, वो भी इसलिए क्योंकि आरएमएस में आ जाएगा आंसर, बट इट्स ओके। अगर हम अभी भी कुछ निकाल रहे हैं तो एक फैक्टर ही है वो, अभी बस मेन आइडिया पे ध्यान दे दो। सो इट्स ओके कि वो आरएमएस में है या नहीं है। सो आई एम अज्यूमिंग कि ये आरएमएस ही है, इट्स ओके। वी आई एम नॉट अज्यूमिंग कि ये पीक है, आई एम अज्यूमिंग आरएमएस है, सो आई डोंट हैव टू डिवाइड इट बाय √2। अगर कुछ नहीं लिखा है सो यू कैन से कि ये मेरी अजम्पशन है, आई एम अज्यूमिंग कि आरएमएस है, क्योंकि क्वेश्चन में दिया ही नहीं है कि क्या है। वैसे ये
नहीं
पीक ही होता है, वैसे
पर
पीक होता
जैसे
है, हाँ यू आर राइट, ये
हाँ
पीक
हाँ
होता है।
हाँ
बट इट्स फाइन, जस्ट टू मेक कैलकुलेशंस इजी आई एम सेइंग ये आरएमएस ही है। बट यू आर राइट, ये पीक ही है क्योंकि वो उन्होंने साइन की टर्म अलग से दिया है। ठीक है,
हाँ
सो यू विल हैव टू डिवाइड √2, बट जस्ट टू शो यू द आइडिया आई एम अज्यूमिंग आरएमएस है। Okay, so once you have done this, so you can convert this into that complex number notation, and this will just be 200 only, plus no imaginary part because the angle is 0. So cos 200 times cos theta plus j sin theta, right? This is 200 times cos 0 plus j sin 0. So this is nothing but 200. Okay. Now your resistor is of 10 ohms, and now you need to find this thing for this 0.1 Henry inductor. So does anyone know how we find this? Okay, this is given by j omega L. J omega L, yes. So this is basically the impedance of your circuit, right? So uh, is everyone of you is familiar with this, right? The concept of impedance. इसके बिना तो कुछ नहीं हो पाएगा. Does anyone not know what impedance is or what reactance is?
ये तो पता है, पर जैसे हम तो 12th में जे नहीं लगाते थे, तो फिर यहाँ पे जे लगाना है, सिर्फ ओमेगा
हाँ
लिखते
क्योंकि
थे।
हाँ, because that was just the reactance, but इधर लगाना है. Okay, so your overall impedance of the circuit becomes 10 plus j. What was the value of L? 0.1 Henry. So this becomes 31.4 ohms. So this is your overall impedance of the circuit. So now to find current, what you can do is you can now you don't have to form any differential equations or anything because you've converted everything into this phasor notation. So you just have to divide this and you'll get the current in the circuit. This is just 200 only, by the way, because your angle was 0, so there was no imaginary part. So if I do this division, if I have time, I'll show you how to do it in Python. For those of you who do not know, I'll show you in the end how we'll do it in Python. Or if you have any calculator, you can put the values there. So if you will do this, you will get your current as, where did I do it? Okay, you will get your current as this: 1.84 minus 5.783. Okay, this will be the expression for my current. Now I can again change it into that modulo and angle form. So if I do that, I will get this. Now again, all of these conversions you don't have to know. You just have to put them in a calculator and they'll calculate it for you. So I'll show you some applications of some apps where you can do this. So this will be your current. And if we have to write it in the time domain, we just follow the same way. Now since we started with sine, so we have to write sine only. So this will be 6.07 sine 314t minus 72.33 degrees. So this will be the expression for your current. So do you have any problem in this? I mean, I know it hasn't been covered in lectures, but
ये जैसे 314t ये तो रेडियन में होगा, फिर डिग्री में लिख सकते हैं ऐसे?
मैंने यहाँ पे एक्सप्लिसिटली लिखा है ना कि ये डिग्रीज है. मैंने मेंशन किया है कि वो डिग्रीज ही है. Okay, so this will be your in general expression of current. But this is just the steady state current. This is not IT, this is actually IS of t. Now, see one thing. If I do I equals 0, what do I get? I get 6.07 into sine of minus 72.33 degrees. Right? But does this even make sense? At t is equal to 0, we had applied the source, but we are getting some value at t is equal to 0, which should not be the case. We should have gotten a 0 over here. So that means that the answer we found is incomplete, and therefore we need to incorporate one more part to the current. At that other part is the transient component. So to find that transient component, I told you that we start by this form of a solution. Tau is the cell by R. And we need to find K. So what we do is I0 is equal to I tau 0 plus I S0. So this means that 0 is equal to K. E term would go to 1 because we are putting 0 plus 6.07 sine of minus 72.33 degrees. And from here you can solve for K. K is equal to minus 6.07 sine of minus 72.33 degrees. So if you do this, your K will come out to be 5.783. And your overall expression for current would become 5.783 e to the power minus t by tau plus the steady state current that we found. So this will be your answer. I mean, if you right now don't understand how these conversions are working, I'll show you in the end using some tools. And for theory, it will be covered in lecture. But in general, if the idea is not clear that why do we have this transient part, or uh, what is a phasor notation, what is impedance, so you can ask all that. But don't worry about these conversions too much, like how is this converted into this, or how this conversion you should know why this is becoming this, because this is the way we started only. I when we started with the sine function, i I ignored the omega part and I only took the phase part, the amplitude and the phase of the signal. So similarly over here we have the amplitude, which is 6.07, and we have the phase of the signal, and we'll just use the same operating frequency which we are given. And since we started with sine, so we have to use sine over here only.
ये इसको फ्रीक्वेंसी डोमेन बोलते हैं, जो ब्लू से लिखा है आपने, मतलब फेजर में.
Hmm. Phasor domain. Okay. So, anyone has any doubts in this? Okay. So let's go to then question number 3. Question number 3 is the exact same question. So you have 1 Henry as your L, you have 50 ohms as your R, you have omega as 314, and your voltage is given by 141 sine 314t. So they're asking you for that transient component of current only, which I showed you. They're asking for this part. So you will do the exact same thing. You will find I steady state current the way I showed you by converting into phasor. You will find this steady state expression, and from that you need to find this transient expression for current. So should I do this, or will you guys be able to do it now? Because they're just asking for the transient part over here. Or I can just give you the answer and you can verify it later. Or do you want me to do this also?
अभी आंसर दे दो, कर लेंगे.
Okay. So your I would be 141 upon 50 plus J 314. ये steady state के लिए है, ठीक है? So in general your I steady state current would become 0.443 sine 314t minus 80.95 degrees. This will be your in general steady state part. And you need to find the transient part, which is the k e to the power minus t by tau, and that would come out to be 0.437 e to the power minus 50t. This will be your answer for transient part. अगर ये किसी से नहीं हो, so please ask me tomorrow in the office hour session. Hopefully, when you have gone through it once, so it will be easier for me to explain it to you again. So अगर ये question नहीं हो पाए, it's okay. So you can ask tomorrow as well. It's fine. ठीक है, but if you want to take a picture or anything, just note it down. Take 1 minute.
It is probably too much to ask for, I guess, but I might be voicing popular opinion. Is it possible that you teach a bit of phaser, maybe a little more in depth, in the office hours tomorrow, if there are like not too many doubts? Because quite honestly, it's not very clear and it's a difficult topic. That is if everyone agrees and you have time. I mean, it's just
I
an
mean,
opinion.
sure, if a lot of you come tomorrow in the office. So, okay, if a lot of you have doubts and phasers, so you can join at 8 p.m. tomorrow. I'll take 15-20 minutes to discuss phaser in the beginning, and then you can ask your quiz or with some doubts.
Okay, thanks a lot.
Hmm.
Can you just tell how to do those calculations once? Just
Yeah,
for
I'll show you in Python only.
okay.
Just let me cover this last question, fourth question. And is everyone fine with first question? First question is a simple LR circuit with a DC source. So you just have a 200 volt supply with LR. It's a normal LR circuit with a DC source. So I hope there's no. And for this flux linkage part, flux linkage just equals to this Li. Okay. I hope this is not a problem. Just let me cover this fourth question, then I'll show you how to do those calculations. Okay. So here we are given I is equal to 50 to the power minus 10t sine 628t. So what they're asking for is they're asking for the time when this will equal to 1/10 of its value. So now whenever you have expressions like these, so understand this, that in these type of problems, this exponential part is the part which will cause a decay, and this just causes some sort of a oscillation, right? Because as time increases, this term will tend towards zero and it will start decreasing the value of this current. But the sine 628t will just keep oscillating. So this is the part which is responsible for decay, the exponential part. Hence it is called exponential decay. So what they're asking is that we need to find the number of oscillations which occur before the amplitude of the oscillation decays to 1/10 of the value. So right now the amplitude is 50. So they are asking when will this change to 5? I mean, after how many oscillations will this amplitude become 5? So does anyone have any idea how to do this?
अभी ये तो e raised to power minus 10t को 1/10 होना पड़ेगा ना, उसके लिए टाइम निकाल सकते.
हाँ, वो ये पूछता है कि ये जो पूरा पार्ट है ये 5 कब हो
हाँ,
जाएगा.
तो टाइम निकाल देंगे ना वो.
हाँ, सो वही तो पूछ रहा हूँ कैसे निकालेंगे.
तो e raised to power minus 10t को 1/10 होना पड़ेगा इसके लिए.
राइट. सो what essentially it means is that कि ये exponential decay part कब 1/10 हो जाएगा. So this is what it is asking. So from here you can solve for t. You will get t as 0.23 seconds. And now to find the number of oscillations, what you are given right now is you are given this omega 628. So this means that your frequency is omega upon 2 pi, because omega equals 2 pi f. So if you'll do this, you will get as 100 hertz. So this will be your frequency, and number of oscillations is nothing but frequency into the time. So you will have 0.23 into 100. So 23 oscillations will be your answer. Is this fine?
भैया एक डाउट था, मतलब क्वेश्चन 3 में जो
कौन से क्वेश्चन में?
क्वेश्चन 3 में जब मतलब इस ट्यूब से पहले मैंने कहीं पर ट्रांजिएंट एलआर सर्किट का सोल्यूशन देखा था, तो उसमें जब उसने इंटीग्रेशन सॉल्व करी थी तो आई नॉट के साथ साइन वाली टर्म भी आई थी, साइन ऑफ -5, आई नॉट साइन ऑफ -5 रेस्ट पावर -t/τ भी आई थी। तो आंसर में तो